Today we're going to look at mass and weight, what they are, why they are different, and why it matters. So we all know what weight is. It's the reading on the balance when you're weighing stuff out. Weight is a measure of the force of gravity acting on an object. That force is a measure of the amount of substance only if the force due to gravity is constant. Fortunately, the strength of gravity on the surface of planet Earth is constant for the vast majority of us, so we use weight to indicate how much of a substance we have. But science has to be precise, not only in terms of accurate numbers, but also in terms of accurate descriptions. If we say that a reaction requires a certain weight of a compound, that statement should hold true for all situations, which it can't. Because whilst weight is dependent upon where a substance is, because of possible changes in gravity, mass is not. Mass is a measure of how much substance you have. I'll show you what I mean. So let's measure out two identical samples of stuff. We know that they are identical amounts because the balances show the same reading and both balances are subject to the same gravitational field. Now let's put one of the samples, still on the balance, in space. We haven't changed the amount of substance, but its weight is different. In fact, it weighs nothing, whilst the mass, the amount of substance, is constant. This is why we must be careful when using these terms. If the quantity you want to specify should change as a function of gravity, use weight. For instance, you could map changes in the gravitational field around the Earth by recording the weight of a particular item from place to place. However, if you want to specify the amount of a substance, you should use mass. Incidentally, if you were to travel to a particular mountain in Peru, you would lose around 1% of your body's weight. However, you would still have the same body mass.